Hello, my name is Bien, and today we are going to talk about quadratic equations and functions, and we are going to solve for their solution sets, and we're going to check on how to graph them and checking on their properties as well. Now, first we're going to talk about solving for solution sets. When we solve solution sets, we usually factor them, factoring, and use the quadratic formula. Formula. I have here three examples you can check out. And the last one is now this two we are going to solve by factoring, and this one we're going to solve by the quadratic equations. X squared minus 4. We know that the possible factors of x squared minus 4 is x plus 2 and x minus 2. So to check, we just have to use the FOIL method again. So to check that, we're going to see that those are the factors of x squared minus 4. So now we have to equate both equations to 0. So x minus 2 equals 0 and x plus 2 equals 0. Just transpose them there. We have two x's. X equals 2, x equals negative 2. So how do we check again? In order to check, we just have to substitute those values to our equation. So 2 squared minus 4 should equal to 0, and negative 2 squared minus 4 should equal to 0. So here, we know that 4 minus 4 is equal to 0 because 2 squared is 4, reduced by 4 again, that's 0, and negative 2 raised to 2 is 4, minus 4 again is equal to 0. So they both check out. So our solution set is 2 and negative 2. Another method we could use is the quadratic formula. If you still remember, your quadratic formula is b plus minus square root of b squared minus 4ac over 2a. Now, what are those a, b, and c's? Now, if you look at your quadratic equation, let's use the example I gave a while ago, minus 3x minus 4 minus 4. We know that the coefficients in front of them, here we have a 1 there, this is your a, this is your b, and this is your c. So that we don't get confused, we write it on a paper. There you go. And now we just have to substitute those values to our equation. Negative 3 plus minus square root of negative 3 squared minus 4 times 1 times negative 4 over 2 times 1, which is equal to 9 plus minus square root of 9 minus 4. Negative 4 times 1 is negative 4 times negative 4, that's positive 16 over 2. Now, that is equal to, if you check that is also equal to 9 plus minus square root of 25 over 2. And we know that the square root of 25 is 5. So we have to check 3 plus minus 5 over 2. We have to check if which is the more appropriate uh, solution set to our equation. So 3 plus 5 divided by 2 is equal to 8 over 2 by 4. The other one is 3 minus 5 over 2 is equal to negative 2 minus 2 or negative 1. So we just substitute the value to our equation, which is x squared minus 3x plus minus 4. Minus 4. So let's go ahead and try the first value of x, which is 4. So x 4 squared minus 3 times 4 minus 4 should equal to 0. This one is 16 minus 12 minus 4 should equal to 0. We know that 16 minus 12 is 4 minus 4 is equal to 0. So 0 is equal to 0. So we now know that this, the value, before is the value of x, it's a solution set of our equation. Now we have to check on the other value, which is x equals negative 1. And negative 1 squared minus 3 times negative 1 minus 4 should be equal to 0. Negative 1 squared is 1. This will be plus 3. It's negative 3 times negative 1 is positive 3 minus 4. And it should equate to 0. So 1 plus 3 is 4. Minus 4 is equal to 0. So 0 is equal to 0. So our solution set for the equation x squared minus 3x minus 4 is 4 and negative 1. We can also check this if we factor these equations. The factor of that equation, as you know, is just to show you x plus 1 x minus 1 minus 4. So if we check the value of x that we showed here is x equals negative 1 and x is positive 4. So we just have to substitute both of values, and that's what we did with the two other equations. So we have the same answer. Now that we've discussed solving for solution sets, we're now going to discuss quadratic functions. Now, if you graph quadratic functions, we call it the parabola. Parabola. Usually a parabola looks like this. Either like that, that's a parabola. This is also a parabola. This is also a parabola. Or this. Also a parabola. And this one. But we are going to discuss quadratic functions. So that means if you say it's a function, if you use the vertical line test, it should just intersect only on one point. So this is intersecting on 2 points. So that means it's not a quadratic function. This intersects 1 point, so this is a quadratic function. This one is a quadratic function as well. However, this one is not, and this one particularly is a quadratic function as well. So what are the properties of a parabola? First, we have concavity. Concavity. That just means if it's pointing upwards or downwards. We also have the vertex. The vertex is the point where it divides. The vertex is the maximum and the minimum point, or the minimum point. Minimum point. The axis of symmetry. Symmetry. This just divides the parabola on equal parts. This is the axis of symmetry. The domain. All possible values of x. The range. All possible values of y. The y-intercept, which is the value of y and x is 0. And the x-intercept, which is the value of x when y is equal to 0. Now, from a graph with the vertex 3 and negative 4, with this equation, squared minus 6 plus 5. So to check the concavity, let's try to graph that. First, we have to solve for the vertex and the y-intercept and x-intercept. We know that when a, or the coefficient here, when the value of a is greater than 0, we know that the concavity is pointing upwards. Now the vertex, we just have to look for the vertex. The formula for the vertex is h. To find the point in the x-axis, it's h equals negative b over 2a. And to find k, which is the point in the y-axis, it's 4ac minus b squared over 2. Oh, I mean over 4a. So we just substitute the values. So that's negative 6 over 2 minus 1 equals 6 divided by 2 or 3. K is 4 times 1 times 5 minus 6 minus negative 6 squared over 4 times 1, which is equal to 20 minus 36 over 4, or negative 16 over 4. 16 over 4 or negative 4. So now we know that the vertex is. So we have the concavity now. Concavity, we know that it's pointing upwards. The vertex is equal to 4. I mean 3 and negative 4. Negative 4. We now just have to find the x-intercept, and the y-intercept. So the y-intercept is very easy to find. You just have to change all the values of x to 0. And with this equation, x squared is equal to, y is equal to x squared minus 6x plus 5. We just changed the values of x to 0. So y is equal to 5. So we now have our y-intercept, which is 0, 5. Now for the x-intercept, it's a little bit trickier. It's either we use the quadratic formula or we factor. But this one is factorable. This is just the possible factors of that formula. So that equation I mean is x minus 5 and x minus 1. So our intercept is 5 and 1. So our x-intercepts are 1, 0 and 5, and my mistake. That should be 5 and 0. Kaya mo naman exactly. 5 and 0, and 1 and 0. 1 and 0. So we just have to plot that in our Cartesian plane. So we know our vertex is 3 and negative 4. So 1, 2, 3, and negative 4, negative 4. So our vertex is here. We know that our y-intercept is 0, 5. So 0, 5 is here. And our x-intercept is 5 and 1. 1 and 5. So now we can plot this. We just connect the dots, just like when we were children. Connect the dots. So there you go. That should be a little more curved, but still the same. So now we can see it in the graph. So we just have to look for the domain, but we all know that the domain, or all possible values of x, when we look at this graph, look at that it's infinitely pointing, so we can assume that the domain is the element of all the numbers. The range, however, is much different. Our lowest point, or our minimum, the vertex, the lowest point is negative 4. And we know that the range, if it's pointing upwards, the range is y should be greater than k. And we know what our value of k is. So the range is all the possible values of y is greater or equal to negative 4. Now the axis of symmetry. We know that the axis of symmetry is the one dividing the parabola in two equal parts. So, and we know that the axis of symmetry should be equal to x. So x should equal to h. Now our h is, we know what h is. It's 3. H is 3. So our axis of symmetry is 3. Axis of symmetry is 3. There you go. We figure out the properties of this parabola. Another example is this function, x squared plus 4x plus 3. First, we write the coefficients first. It's much easier for us to solve later. 4, 3. Next is, we know that our a is greater than 1, so we now know that our concavity is upwards. We just have to look for the vertex, the y-intercept, the x-intercept, the axis of symmetry, the domain, and its range. Now we can all find those once we compute for the vertex and the x and y intercept. So the vertex, we know that the formula for the vertex is h equals negative b over 2a. In this case, negative 4 over 2 or negative 2. And the k is 4ac minus b squared over 4 is equal to 4 times 1 times 3 minus 4 squared over 4 times 1 is equal to 12 minus 16 over 4 or negative 1. So our vertex is 4 minus our vertex is negative 2 and negative 1. So we just have to compute for the x and the y intercept. Let's delete this to look for the x and the y. So for the y-intercept, you simply just exchange the values of x to zeros. 0 to plus 4 times 0 plus 3. So the y-intercept is 0 and 3. Now for the x-intercept, it's a bit trickier. It's a bit trickier because you have to factor to use the quadratic formula. In this case, we can just use the factoring because that's much easier. So we know that the factors of that quadratic equation is x plus 3 and x plus 1. So you just solve for x. So this is negative 3 plus negative 1. So our x-intercepts are negative 3 and negative 1. So now we have our two intercepts and our vertex. We can start graphing this. So that's 2 and negative 1. Negative 2 and negative 1. So negative 2 and negative 1. So this is our vertex. Our y-intercept is 3. Our x-intercepts are at negative 3 and negative 1. So if you graph that, it looks like this. That looks like a parabola. Now, the axis of symmetry is x should equal h. X should equal h. We know what our h is. Our h is negative 3. So our axis of symmetry, which is this one, is negative 2. The domain is, as for all quadratic equations, if you look at the graph, this is goes infinity and that goes infinity, so it's both positive and negative. We can assume that the values of x are all real numbers. But as for y, for the range, however, we check on the minimum point. Minimum point, which is negative 1. So we know that if our k, so we know that if y is less than k, the concavity is upwards. If that is upwards, our range should be all the values of y should be greater than or equal to, where k is negative 1. So now we have all the properties of the parabola of the equation x squared plus 4x plus 3. Now that we've learned how to solve equations and graph them, we're going to learn how to get the properties of a parabola by just looking at, at its image. So first, we list down the properties: concavity, 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 its vertex, its symmetry, axis of symmetry, axis of symmetry, its domain, its range, the y-intercept, and the x-intercept. So we know that if the parabola is pointing upwards, it's very easy, as you can see that it's pointing upwards, so the concavity is upwards. The vertex is the lowest point of the parabola. So you can see there, the lowest point is at 1 and -4. So just write 1, -4. Axis of symmetry is where it is equally divided. So axis of symmetry is 1. Axis of symmetry is 1. The domain are all possible values of x. If you look at the parabola, it's infinite. So x are the elements of all real numbers. Y, however, is, we have a limit here. The minimum point of is -4. So our range are y, the values of y, should be greater than or equal to -4. The y-intercept is where it first reaches. It intersects the y-axis, which is -3, and the x-intercepts are where the points where it reaches the x-axis, which is 1, -1, and 3. See, if you're looking at the parabola, it's much easier. Another example is this parabola. Again, list down its properties: concavity, concavity, its vertex, its axis of symmetry, axis of symmetry, its domain, its range, the y-intercept, and the x-intercept. Again, concavity, it's pointing upwards, so it's quite easy. Concavity is upwards. Vertex, you just look at the point, and where is the lowest point? It's on -2 and -1. -2, -1. Axis of symmetry, where is it divided into equal parts? It's on -2. Domain again is, if you can see, values of x are infinite, so x, element of all real numbers. Y, however, what is our lowest point? Our lowest point is -1. So the values of y should be greater than or equal to 1. For the y-intercept, first time it reaches the y-axis is at 3. It's the y-intercept. The x-intercepts are -3, -3, and -1. So you can see it's very easy. Once you have the parabola there, you just have to know what the properties are, and once you know them, just list them down, list the points, and quite easy. Now, I hope you learned a lot of things from our discussions on quadratic equations and functions. And first, for solving solution sets, and second, for quadratic functions, graphing them and noting